Okay, so I'm Ben. I work for Wix at front-end development for the premium team. I want to talk about functional programming in JavaScript, and actually practical functional programming. I'm not just adding that word for nothing. I think a lot of talks about functional programming today are super advanced, and they talk about very high, very complicated concepts. I'm not going to go into the complicated parts. I'm going to stay pretty on the surface, just because I think a lot of people are missing that part, and I want you to get it. So let's go on. Okay, so what's so great about functional programming? Why do I want to talk about it? Why do I like it? So for the next 45 minutes, I am going to talk about why I like why you should like functional programming, why you shouldn't, some of the basic concepts. What are the benefits of this paradigm? Well, if you're using these concepts, what are you going to get from it? And some more advanced stuff, like the cool stuff, okay? Okay. So I'll start off with what's not better about functional programming. And, well, it's just not better. I mean, I'm not here to tell you that you should always do functional programming. That'll be a mistake. It's just a different paradigm. Object-oriented is one paradigm. You have different paradigms, others. And I'm not going to tell you that you should use always one. You should always consider your circumstances. OK. So like I said, it's better suited for certain types of operations and ill-fitted for others. And let's OK, the clicker is not working very great. OK, so let's see what is it good for. So stateless operations, a lot of times server code, like services, are stateless. And if they're not, they should be. And in these cases, a lot of time functional programming helps because there's no state, obviously. So you can just write functional code. Algorithms, it's kind of the same concept. When you do data analysis, sometimes when you have, even on a client, you have a service that takes data and returns some kind of aggregation on that data. In those cases, functional code is great. Also, handling events, and it's really good for testing. You know, I'll show you more examples later of everything here, but generally, I mean, when you test something with input and output, it's much easier to test. You can understand why. So when is it not great? In my opinion, like when you have a real state in the like wizards or that kind of UI, sometimes you just want to have state. And in these cases, a class could sometimes, with a state, could sometimes give you a better service. And sometimes, you know, functional code has, in today's JavaScript, to my experience, it has less advantage with speed. If you use loops, sometimes they're just better than recursions, for example. Also, with my experience, it takes time to get used to writing functional code. You have to practice it before you're really good at it. And even to read functional code. I have people who work with me and writing my code, which is somewhat functional anyway. They used to ask me to explain what the heck this code does. So it's not that simple. Now, I want to talk about Back to the Future, because I think it's really funny how Back to the Future awkwardly predicted the future wrong. For example, like this is how they thought cool people would dress in 2015. And you know, that's just awkward, even if you think of 30 years in the future. Or hoverboards, like that's pretty weird. And actually, how they thought Michael J. Fox would look when he'd be 47, when he actually looks like this in 49. So those are awkward future predictions, in my opinion. And the reason I'm showing you this is because I guessed the future better. When I gave this talk 3 years ago, I actually kind of predicted that functional programming would be a trend, I think, like giving myself credits here. So what I said back then is, I had to give like examples of languages that are somewhat functional. For example, Scala or link extensions. And today, I don't need these examples. I have Redux, and I have Immutable.js. Everyone knows what Redux today here, and everyone knows that functional programming is like a really hot trend right now. Like if you Google on YouTube, you get so many talks about it. Almost make this one redundant. Okay, also you have languages. These are all functional languages that transpile into JavaScript. I recommend trying them just to get the hang of what it means to write real functional code, because JavaScript is a hybrid in the end, and there's always trade-offs. And it's so much trend, it's really cool. Okay, so I'll start off with the concepts, okay? Like these are the core concepts of functional programming. If you have to understand these are like building blocks that you need to know. So what is immutability? Immutability means that when you have an object, you never modify it. You create new objects that have the modifications on them. There's a lot of advantages to that. React uses it a lot, Redux too. I'm not going to go into how they are used, but I'll give you an example of what immutability means. So if you have code like this, you have this array. It goes through map that adds a 1 to each one of its values, and then it goes, it's filtered. Now this array is a new array than from this. I mean, you don't actually change the values in this one. Once you go here, this one's, unless you, once you go here, this array is actually thrown because there's no reference to it, and there's no need to keep it in memory. So this is when I said like sometimes speed is not the most beneficial. Sometimes this causes actually slowdowns, but you'd be surprised how in large frameworks this usually causes big speed ups, especially when you need to compare. You can compare by reference instead of by value, and that's the biggest benefit. Oh man, I'm gonna have a problem with this. Okay, another really important concept is first-class functions. So these are functions that can be passed around. That's basically what it means. You can pass a function into a function. Higher order functions, that's how you call them. They're useful to avoid state, and they're useful to abstract solution. And let me give you an example. This function is a function that given a max value. This is, by the way, does anybody here know what an arrow function is? What it means? Okay, you don't know what arrow function?
Yes, we know. So yeah.
Okay, that's what I want to know because. Yeah, okay, that's what I want. Okay, so raise your hands if you know what arrow functions are. Okay, cool. So I'll just explain because not everybody raised their hands. It basically means that this is the parameters of the function, and the result of this arrow means that this is the result. So if you give it max and number, you get the maximum of max and number. Okay, so if this is like the previous max. If max was 1 and number was 3, then this is a function that will give you 3. Now, if I pass this function, I'm going to use this. Okay, so if you pass this function to max into the reduce of this array, you will get 4, which is the maximum. Now, if you switch this function by something else, in this case, this is a function. I mean, this is the mathematical notation, but it means if you want to calculate a new average and you have the old average, you have this formula. I don't need to go into details. I just want to tell you that this is the equivalent, the JavaScript equivalent. You take an average, you add something, and it creates a new average. And then if you take the exact same line, but instead of 2 max, you put 2 average, okay? You get the average of this array. And this is a basic concept in functional programming. We separated the values and the function, the logic. And that allowed us pretty nice operability between these two concepts. I'll show you a lot of these, don't worry. Okay, so I'm going to talk about inc. Inc is a very complicated function. It takes values and adds 1. So if you take 4, you get a 5. For 0, you get a 1. For 199, you get 200. And for 2035? 2036. Exactly. Good, you guys are good. I should have known this is advanced. Okay. So we'll look at 3 ways to implement this using higher order functions. There are different ways to do it. So number 1, Okay. We'll use an arrow function. This is actually, and I'll show you what I mean, a function that returns a function. Look, this I needed. Oh, damn it. So I'm adding these round brackets because this is a function that takes b and returns a, which is from the outside, plus b. And this is a function that takes a and returns a function that takes b that returns the addition. So this is a higher order function, a function that returns a function. Okay? And when I run this function, the big one, on 1, what I get is this function that the a is 1. So you get, if you give it b, you get 1 plus b. And that's why you get inc. If I've given it something like -1, I'd get dec, like decrement. And this is a reuse of a function as a higher order function. Let's see another similar example. So this is another way to do it. This is the old school way. You take a regular function and you just bind it to a value. This is JavaScript ES5. It existed a long time ago. Undefined is just this. It doesn't matter here for this example. So this basically means take this function and bind the first value to 1. So again, it returns 1 plus b, which is surprisingly inc. OK, there's another concept. It's called carrying. Carrying means you take a function. OK? You take this function, and you create a new function. Everything here we'll be talking about functions, taking functions, returning new functions. So I'm sorry if this is a little confusing. Please just raise your hand. I'll explain it 5 times if I have to. But basically, what this carry, what it does, it takes a function, and it returns a function that when you pass a parameter, like for example, if you pass 1 parameter, it returns a function expecting the second parameter. It's kind of like the partial application that we've seen, but it's very dynamic. Without going into too much explanation, you can play around with it later. Again, you do the same as we've seen before. You give it 1, and then you return a function that, given 6, returns 7, or 2 returns 3. And this is very, very helpful for functional programming. Why? I mean, well, we'll see in the rest of the talk. OK. So when we work with functions, we can't just use any function because we have some certain expectations. One of the expectations is that our function would be stateless. What does it mean to be stateless? It means that it doesn't use any values that exist outside the function. For example, global variables. It can't do an AJAX call. It can't access the window or a DOM in any way. The only thing it takes is the parameter of the function, and it returns the value based on these parameters. That's what stateless means. No side effects. It's kind of the same, but outward. It can't create side effects. If it does an AJAX request, for example, that's a side effect. It will influence something in the outside world. You can't do that. And if you take these two and combine them, you get that for every x, f of x will always be the same. This sounds mathematical, not by chance. Functional derives a lot of its abilities from being very mathematical. And if all of these applied, we're calling these pure functions. Okay, pure functions are functions that abide to all these rules. So this is purity. I'll give you an example in JavaScript. We have splice and slice. I'll give you a little bit background. Splice is the function that given this array and the number 1, changes the array, the one it ran of, and actually removes the first. If this is 1, it starts the array from 2. So, like, it removes the first element. So it actually returns the element removed, which in this case would be 1. 1 is the index, yeah? It's not value. And this value will be changed. Slice works differently. It's very similar, but it's stateless. So if you run slice on this function, you get as a result the array 2, 3. But this array doesn't change. It doesn't touch the existing array. So when we do functional code, we'll want to use slice, not splice. Okay? So I kind of answered the question. Slice is the pure one. Okay, so why do we even need all this? Why? Well, I mean, there's some concepts here, but what does it help us? How does it help us? One thing it allows us to do is automatic compiler optimizations. So for example, look at these three functions. You have x that's dependent on the function f, and you have y that's dependent on the function g and the value from the previous line. So to calculate y, you have to run both g and f. But if you look at z, okay, actually you don't use the value z anywhere. You only use y to console log here, and that's important because in practice, what it means here that you don't actually need this line. You can just remove it and never call for f, okay? Because the value of z is never used. What is it? Now, why can we do it? If f had some kind of a side effect, we couldn't have done this because we couldn't know that removing this line could somehow impact or not impact our application. But now we know because we know that f is a pure function. We know we can remove it because removing it doesn't change anything in the outside of the function. So this is really important. You can just remove this. A compiler can do this automatically if it knows that these are pure functions. By the way, guys, stop me at any time. It's OK. Okay. Another concept, I mean, it's not a concept. It's actually a nice thing to have in functional programming is memoization. It's a funny word, but it means basically cache. Okay. So if you have this function, which is pure, and you run memoirs on it, you actually wrap it with a function. You get a new function that has cache automatically built in. It just looks on the parameters and recalls the output of the function, so you don't have to call it again with the same parameters. So for example, if I run it with 2 and 3 and I get 5, we can see that add is called because this is the first time you call it. And then you call it with different parameters, 1 and 3, and you get 4 because 1 and 3 is different than 2 and 3. But if you call it the third time, add is not called. And that's a really big benefit. Like, think about large systems with a lot of algorithms and a lot of calculations. This could save many, many cycles. And it's used a lot. Like, if you know Mobix, it does this to save a lot of calls.
How do you
Yeah, go ahead. How does memoirs work? Yeah. OK, the question was, how does memoirs work? So what it does, well, there are different implementations, but the basic idea is that it recalls how many parameters it has. It creates a key based on these parameters for a hash table. And what like madd passes 2 and 3. It sees that there's 2 and 3. It recalls 2 and 3, passes it to add internally, gets the result from add, stores it in a hash table. So it stores 2 and 3, the value is 5, okay? And then returns 5. And next time you call 2 and 3, it'll check in the hash table to see if it's there. Okay.
This is done automatically by JavaScript?
No. Memoirs is not. This function is not built into JavaScript. Sorry, this is a library function.
Not just a name, it's a keyword.
It's not a keyword. Memoirs is, I'm sorry, maybe I should have said it. Huh? It's a third party. I mean, there are many implementations for. It's a concept. Memoirs is a concept of what to do to a function, but the implementation is not part of JavaScript. It's third party libraries provide it, but it's not part of JavaScript. OK.
How do you clear the cache?
How do you clear the cache? Each library provides its own API. So parallelization. So let's say you take these two functions. They're not related. This is part of being stateless. That's what it means. They have nothing to do with each other. So there is no reason why not to run them together in different threads and get the results sooner, and then add the value. But you can't really do it in JavaScript because you can't run two things together in JavaScript. But as a concept, like it's important to understand this because if you ran on a server, you can actually do this. OK, I want to explain for a second why functional code is really good for testing, because I think it's really good for testing. It's really worth to know this. So if you've ever run tests, and I sure hope, I mean, most of you did, you know that most testing libraries like Jasmine or Mocha, test runners, actually look like this. You get before each, which is sort of like it's the thing that runs before all the tests. It's called the setup. And then you have the test, and you have some more setup, and probably some kind of an action expectation. And then you have the after each, which clears. Now, usually the setup means side effect, like mocking the server code, et cetera, or BI, like mocking external APIs. Now, if you have different setups per test, you sometimes do this. You have like different describes because different tests require different setups, and this happens a lot. So what functional gives you is cut all the shit down and just work with the actual function. You just want to call the function with a value. Okay, no. Call a function with the value and check the output. That's all. There's no setup for functional code. And this works with components. If you have a functional component, meaning there's no state for the component, and there's no dependency on API, I can assure you this is very doable. I've done it in my project. And this is how a test usually looks in these cases. And it's really nice because it's really easy to detect problems when there is no side effect. OK.
Can I ask questions?
Yeah.
Is cache not a kind of side effect?
Cache is yes, that's a good question. Cache is kind of a side effect. But in this case, it's very controlled, I think. There's no, I mean, if you know exactly what it does and it's very controlled, I think you can take, I mean, but it is a side effect. There's no question. It's definitely a side effect. Sometimes you can have some kind of trade-off to get certain speed. But yeah, you're right. I didn't. I
had trouble in this case.
You notice I didn't show it as a concept, just as a benefit, and that's why, because it's really just a benefit. Okay. Something important that you need to understand in functional is, and this is really, I mean, it's not directly related to functional, but if you write functional code, you'll probably also be writing declarative code. And what does declarative mean? So, this picture is really pixelated, so I'm just now seeing it. I'll remember it for next time. Because on this screen, it doesn't look like that. OK. So like I'll start with imperative code. Imperative code is what most of you probably have done. You take some kind of a state, and you mutate it. You change it through instructions. For example, a loop is an imperative way to change a state. And then when like a function, when it finishes with the loops, and whatever you did with that global state, you just return the value. So that's imperative. And that's kind of like a recipe for like preparing a cake. You take the materials, you get instructions of what needs to be done with these materials, and when you finish, you got a cake, and that's your output. Now, so what's declarative? Declarative, I'd say it's kind of like a menu. Like if you go to a restaurant, and you have a declaration of the kind of food that the restaurant has. It doesn't tell you how to prepare it. Just tells you what the cake has, like if it has strawberries or vanilla or whatever. So that's declarative code. And that's like really abstract explanation. So let me show you a real example. This function reverses an array, OK? If you can see here, you take the values of the opposing sides of the array, like a mirror, and you just switch them until you reach the center. And that reverses the array. Now this is imperative. Why? Because it explains through a loop. It tells you, go for each cell, one by one, and switch it with the one on the other side of the array. So that's instructions on how to reverse an array. I painted this on a piece of paper today. I feel very proud of myself. This is a declarative way to reverse an array. And first of all, you'll notice it's actually a recursion, because here we're calling reverse again on a smaller array. Now, let me explain to you what's going on here to make it clear. This is the input of the reverse. It's actually destructuring. It's an ES6 feature for JavaScript. It means that you take the whole array, okay? And you separate it by destructuring. This is the first value of that array, and this is the rest of it. And we put the rest of it into a variable called ARR, array. And then what we return is the rest of the array. We reverse it recursively until we reach the end of it. And we put the first element at the end, okay? So this is a recursive way to explain how to reverse an array. And this works. If you run this function on an array, it will reverse it. So recursions are declarative, which is pretty cool. It's almost for free. Another imperative example is how to manipulate DOM. If you've worked with jQuery, and who hasn't, it's not a question, everyone did, knows that, oops, what did I do? Okay, well. So you take an element in jQuery or in vanilla DOM, and you just manipulate it. In this case, you take a container, and then you create a button, and you put the button on the container, and you put the onClick on the button, and you tell it to add a class to the class list. So this is an imperative way to create a button. Now, a declarative way to create a button would be this. This is the definition of the button, and this is the definition of its properties. And when you click, that's what it'll do on click. And the classes are just the state. By the way, this is state, so it's not really a stateless button, but we're not talking about stateless. We're just talking about declarative code, so that's cool. So declarative code is basically what pattern matching tries to be. JavaScript doesn't have pattern matching, but there is a suggestion to add pattern matching to JavaScript. And this is what it will look like. You will have, so for example, if you have a value who is an array, and there are two values in that array, so this will return the addition of the two values. Same for object. If there are two values with keys x and y, it'll return some kind of a whatever. And if it's if the value is just the string hello, it will return 7. So this is very early stage proposal. Don't expect it anytime soon. So like I showed you before, functional programming likes recursions. And the reason is that loops, which are the opposite of recursions, I'm not exactly opposite, but it's the other concept, they have a state, and we don't like state. And loops are imperative, like I showed you in the example. Recursions are declarative, like I showed you in the example. Recursions are basically a function that takes the previous state and returns the next state. If you've done Redux, you know it's the exact idea of reducers. OK. Let's look at an example of function composition. What is function composition? And this is a really important concept in functional programming. This is a value, and this is the list of functions that you run on this value to achieve the value you want. In this case, you take the array and you map each one of its values to 2 times that value, so you get this array. And then you filter it through all the numbers that are divided by 3. And then you add all these numbers to get 36. So this is starting to be more functional because we're using functions to describe what to do with this. The only problem here is that it's really hard to separate the functions from the value. We can't remove this value and use it and use another value with these functions unless you wrap it with a function, but that's a different example. So the right way to do this, like the functional pure way to do this, is to create a function by composing. Pipe is another word for compose. Doesn't matter the details. You take the 3 functions, you connect them together through composition, and this returns a function. And the function that returns, you run it on object. And I'll show you an example now, what it means. So let's say we have these 3 functions that I show you. One is called doubled, one is called 3divisible, and one is add. This is the exact same output we're going to get, only we're going to separate the logic from the value. And this is the idea with function composition. Then you take these 3 values and you compose them using pipe. Just if you're curious, pipe is the reverse order of compose. It's just a little easier to read for people who are not used to it. Okay, and then you run the new function that's called manipulate on, this is just an array from 1 to 10. And you get 36 again, okay? So we have the basic functions. Then we have the composition that we created. It still has, at this point, there is no value related. We can do whatever we want with it. And then we just run it on a value and we get the actual number that we wanted. So it's better than chaining because it separates concerns. Now let's take this idea, and instead of running it on a big array, like this example, if we had 1,000 values in the array, it would take a long time to run, okay? But what would we do if we wanted to just take 2 items from an array of thousands? How could we do this? So lazy evaluation is the way to do this, and I'll show you how it works. Right after I drink this. So you take a big array, like this. Let's imagine this is 1,000 items, and you run map on it. Okay, this is not a lazy. I'm showing you like how the non-lazy version works. And then you take these new items, and you filter them, because you only like all the numbers that are divisible by 3, like the example. And then you get like a subset. So if this one had 1,000, this would have like 300, whatever. But you only wanted 2 of these. You only wanted the first and the second. So you just take 2. Now, let's do a really quick analysis on this and see how much space and time this takes. So let's say we had 1,000. And then map ran, and we still had 1,000. It took 1,000 units of time and created a new array with 1,000 units. And then running filter on these took 1,000. And this is, I'm writing 1,000. It's less, but it's the order of 1,000. OK, when we finish this, we have 2,000. It took around 2,000 units of time and 3,000 units of space. That's a lot. Like if you think of big numbers, this is a lot of time and space. If you use lazy evaluation here, first of all, we know that we're going only to take 2. And that changes how we look at these. So lazy means we take 1 by 1 until we've reached those 2. So let's see. We take the first one. We map it. We filter it. It passes the filter. And we take it. So we have 1. Then we start with the second one. We map it. We go to filter. Filter stops it. And then we go to the third one. Same thing until we reach the end. And we have 2 items. So we stop. And it took a lot less time because we actually only analyzed 3 items out of the 1,000 outside. So if we do a quick analysis here, we see that the space, we still have 1,000 because we started out with an array of the size 1,000. We couldn't escape that part. But time took us only 6 plus some kind of constant because we don't know how much filter would filter out. And like I said, there's still 1,000 in there. And we want to take that 1,000 out. We want to make it a constant. How do we do this? So if we had a generator function instead of an array. So let's put a generator function here. We could generate the values without actually holding the array. For example, if we're looking at a database, we could generate functions from the database as we go and save a lot of space. And in this case, let's just skip to the end. We eliminated 1,000 here. So this is very beneficial. This is lazy evaluation. And I'll show you like a very small code snippet that shows how to do this. This is a library called lazy. You wrap the function. In this case, just a function that gives you 1, 2, 3, 4, 5, 6. And in this case, you take the first 5 numbers. So you get 1 to 5. And then you can map and get the power of 2. You filter these. You still get the 5 numbers because we told it take 5. I mean, until it reaches the 5th number, it won't stop. So this could have run more times than 5, but it'll stop as soon as it has its 5 values. And then we do whatever we want with it. In this case, we sort it. So this is a pretty nice example of lazy, but there's one problem here. It's not really a real-world problem because we had a function, a synchronous function, that generated the numbers. We never have synchronous functions generate values for us in real code, because we always get the values from a file or from a server or from any type of some asynchronous data source. And even events are sort of like user interface events are the type of data source. And we can look at it as an array of asynchronous values. And I'll show you what it means. So like I said, UA doesn't think that way. So let's rethink events. Instead of being events that we pull, we'll think of events as events that are pushed to us, like user interaction. We don't know when the next one will arrive. And this is an example. This is an async generator. Yael will give you like more details on this. It's pretty cool. It's like very, very new for JavaScript, this kind of API. And what it does, it just creates, I said I gave it 999, but you can say infinite set of numbers, and each number is returned as a promise. This emulates like a file read when you get like 500 or whatever infinite text from a document, and each read takes 500 milliseconds. So this actually, when you do yield here, you get a promise, and the promise takes 500 milliseconds to run and returns a value in a promise. So let's see how we use this. So this is exactly like we did with lazy, but this time it's asynchronous. So it looks the same. If you look at it, you do a wrap, you wrap the generator, and then you run map on it, and then you map it again, and then you take the first 3 values and you print it. And in this case, you will get the array of 2, 4, 6 because you added 1 and multiplied by 2. But what you don't see here is that this actually ran by waiting for gennums to return a value every time. So if gennum, for example, was generate user events, you could have treated it, you could have done some really cool stuff. I'll give you an example of that with nice drawings in a second. But what I want to say, this is another example that does something similar, but with for each. With the latest don't try to read the code. With the latest JavaScript, this is the whole library that allows this. This is very similar to RxJS. If anyone here worked with RxJS, this is like a very naive basic implementation of RxJS. And with the current JavaScript, it's really easy to write with async generators. So it's really important for me to emphasize that there's a big difference between synchronous code and asynchronous code events. That synchronous code is code that you decide where to pull the next value. Asynchronous events are events that you don't choose when. They arrive whenever they are ready, and you have to handle them somehow in a generic way. And if this rings a bell, it's the concept of reactive programming, functional reactive programming, where the idea here is that everything is a stream. It's a stream of events. So the idea here is that we relate to events as a temporal event, a stream of events, meaning the events arrive over time indefinitely. You don't know if they're ever going to end. You just treat them as they come. And that's why you can't wait for all the events to arrive and just do something once they do. So you have to treat them as a stream. So let's see. I'll give you an example. This is like the last thing I'll show you. And this is like really advanced stuff. Like if you have libraries, RxJS works with React, and you can make treating side effects like the UI events very generic and very nice way to handle it. So like I said, think of streams as an infinite array of ongoing events. And let's see the example. So you start. These are clicks. Okay, I'm going to show you how to detect double clicks on a user interface. Okay, and this is a stream of clicks, and you can see they don't come every 500 millisecond, or you just click whenever user wants to click. This represents a click, and how you handle it is you run buffer, which with throttle, which means that if the clicks were clicked within 250 milliseconds. Group them together, do a buffer. Okay, so this is what the array, this is what it will look like as you go. It will create these buffers, but But it won't actually create those because we're already mapping each one of these into the length of the list. So in this case, you'll have 1, which is the size of the first one, 2 is the size of the second one, 3 is the size of the third one, and 1 of the last one. So at this point, you'll have a stream of events that are mapped into 1, 2, 3. They represent the number of clicks together. So what we're interested here at this point is just those that are big, like higher than 1, like double clicks or more. Let's call it, let's call 3 double click 2. So we're filtering everything that's bigger than 2. And we're left with these. There's 2 and 3. And these are double clicks. And now you can take this stream, and you can use a for each to handle whatever you want and do whatever you want in the UI with it. And this is a declarative way to handle double clicks. If you ever tried to handle double clicks without stream manipulation, you'd find it very difficult. It's really hard. I tried it. It's really, really hard. Last thing I want to talk about is monads. No, just kidding. I said I won't speak of monads, so I'm not going to speak. And that's it. So yeah, if anyone has any questions, you're in shock. Okay. Yeah.
When you said you can pass functions as an element, the parameters or non-parameters. Can you pass a function, for example, that takes the value from a DOM field?
From a what field?
The value from a field on the DOM. Okay, you pass the function that takes the value. So the function is still a pure function. The parameter changes according to the value.
Yes, definitely. I mean, you can. Okay, the question is, can you pass a function that takes values from the DOM, and then that way, like, you're asking if that's considered a side effect, right? Basically.
That's still a pure function.
It's still a pure function as long as you don't do any other DOM manipulation inside. As long as everything it does, it takes a component or a value of whatever from the DOM, does whatever it needs to do with that value, and returns the output. There's no side effect. There's no DOM manipulation, no Ajax. Yeah, that's a pure function. Pure functions are what takes the value, does nothing other than return a value based on that parameter. Okay. Thank you.